On October 28, 1893, a vessel of approximately 240 tons was completing her contractor's sea trials in the waters off the English coast, making a sustained speed that no warship of her size had previously achieved, and demonstrating that the design concept she embodied was not merely theoretically viable, but physically real. She was HMS Havock, the first torpedo boat destroyer, built to contract specification by Yarrow and Company at their Poplar shipyard on the Thames. She had made 26.5 knots over the measured mile, exceeding the contract requirement and confirming in the most direct way available that the problem her designers had been given was solvable. The problem was the torpedo boat. The solution was the ship. What those trials produced was not merely a fast vessel. They produced a template, a set of characteristics, and a tactical concept that would be copied, refined, scaled, and elaborated by every major naval power on Earth for the next century and beyond. The destroyer, the type that the Havock defined at its inception, became the most numerous class of major warship in the world, and remains so today. Every modern destroyer, from the American Arleigh Burke class with its Aegis radar and its Tomahawk missiles to the British Type 45 with its anti-ballistic missile capability, traces its genealogy directly and without interruption to the decisions made about the Havock's design in the offices of Yarrow and Company and the Director of Naval Construction in the early 1890s. The lineage is real, and the inheritance is unmistakable, though the ship that received the inheritance would not recognize the ancestor. To understand what the Havock was and why her existence mattered, it is necessary to understand the specific moment in naval history in which she appeared, the technological and tactical context that made her not merely useful but urgently necessary, and the specific failure of existing ship types to address a threat that was becoming impossible to ignore. The Whitehead torpedo, introduced into naval service in the late 1860s, had by the 1880s transformed the calculus of naval warfare in a way that the admiralties of every major power had absorbed intellectually, but had not yet resolved operationally. The torpedo was a self-propelled underwater weapon that could be carried by a small, cheap vessel and delivered against the hull of the largest and most expensive warship afloat. The arithmetic of this relationship was deeply disturbing to naval establishments whose entire investment in capital ships was predicated on the assumption that the capital ship's firepower would be decisive against any threat it might encounter. A battleship that could be sunk by a torpedo boat costing a few £1,000s represented an investment in naval power that was potentially nullified by the cheapest vessel in any navy. The torpedo boat had been developed rapidly through the 1870s and 1880s precisely because this arithmetic was so compelling. Small shipyards that could not compete with the great naval dockyards in the construction of capital ships could build torpedo boats. Nations that could not afford battleship fleets could afford torpedo boat flotillas. Inventors and naval theorists who had argued that the age of the capital ship was ending found in the torpedo boat their most compelling practical argument. By the late 1880s, the torpedo boat had been adopted by the navies of France, Germany, Russia, Italy, Japan, and numerous smaller powers, and was being actively developed and improved in all of them. The specific characteristics that made torpedo boats threatening also made them difficult to counter with existing ship types. They were fast, capable of 20 or more knots by the late 1880s, which was faster than any battleship then in service. They were small, which made them difficult to observe at night, and difficult to hit with the slow-firing heavy guns of the battleships and cruisers. They were numerous because their low cost allowed a naval power to build them in quantity, and a large number of torpedo boats attacking simultaneously could overwhelm the defensive capacity of even the most powerful warship. They were effective at night, when their small profile made them nearly invisible, and the long-range accuracy of the defending ship's guns was degraded by the inability to observe fall of shot. The tactical response that the navies of the major powers had developed by the early 1890s was inadequate. Larger torpedo boats, sometimes called torpedo gunboats or first-class torpedo boats, had been built to chase and engage smaller torpedo boats. They were faster than the warships they were designed to protect, but were not fast enough to reliably catch the torpedo boats they were supposed to destroy. Their guns were too light to kill a torpedo boat quickly, and their torpedo armament made them dangerous to the capital ships they were trying to protect almost as much as the actual torpedo boats were. The torpedo gunboat was a compromise that satisfied none of the requirements it was supposed to address. The question of what kind of ship was actually needed was being worked on in several places simultaneously in the early 1890s. The director of naval construction at the Admiralty, William Henry White, had been analyzing the problem with the thoroughness that his position demanded, and had arrived at a set of specifications that described the ship needed, without yet identifying how to build it. The ship needed to be faster than any torpedo boat, which meant at least 27 knots, a speed that had never been achieved in a vessel designed for sustained operation in fleet conditions rather than for a single measured-mile sprint in calm water. It needed to be armed with quick-firing guns of sufficient caliber to kill a torpedo boat quickly, not the slow-loading heavy weapons of capital ships, but lighter weapons capable of a high rate of fire and of being aimed rapidly at a fast-moving small target. It needed to carry torpedo tubes of its own, both for offensive use against larger warships and as a deterrent to the torpedo boats it was designed to destroy. And it needed to be seaworthy enough to operate in the North Sea in winter, the operational environment for which the Royal Navy was primarily preparing, which imposed requirements for hull strength and freeboard that were difficult to reconcile with the weight and volume constraints of a fast, small vessel. White's specifications were not a design. They were a set of performance requirements that he presented to the commercial shipbuilders who competed for Royal Navy contracts, asking them to produce designs that met the requirements. The two firms that responded with the most promising designs were Yarrow and Company of Poplar and Thornycroft of Chiswick, both on the Thames. John Isaac Thornycroft and Alfred Fernandez Yarrow were the two leading figures in the construction of fast steam vessels in Britain, men who had spent their careers pushing the limits of what could be achieved in small, high-speed craft, and who had accumulated in their design offices and their workshops a body of practical knowledge about fast hull forms, efficient steam machinery, and the construction techniques that made speed achievable in practice rather than only in theory. Yarrow's design for what would become HMS Havock was produced in response to White's specifications and represented a synthesis of everything Yarrow knew about fast small vessels applied to the specific tactical requirements of the torpedo boat destroyer. The hull form Yarrow adopted was a long, narrow shape, with a sharp bow designed to cut through head seas rather than ride over them, giving the ship the ability to maintain speed in conditions that would have reduced a beamier hull to a much lower effective velocity. The length-to-beam ratio, the relationship between the ship's length and her width at the waterline, was significantly higher than the ratios used in conventional warship design, producing a hull that was fast in smooth water and reasonably handy in moderate seas, but that would prove challenging in the severe conditions of the northern North Sea. The machinery installation that Yarrow designed for the Havock was the most critical element of the design, because achieving 27 knots in a hull of 240 tons required machinery of an efficiency and a power-to-weight ratio that the naval engineering of the early 1890s had only barely achieved. Yarrow used locomotive-type boilers, a design that he had been developing and refining for years, and that produced steam at higher rates than the existing marine boilers in common use, operating at pressures of approximately 150 pounds per square inch, and producing steam at rates that allowed sustained high-power operation rather than the brief sprints that the torpedo boats of the period achieved at the cost of mechanical endurance. The boilers were connected to a triple-expansion steam engine, the standard type for high-efficiency marine propulsion in the period, which expanded the steam through 3 successive stages at decreasing pressures to extract the maximum work from each unit of steam generated. The combination of Yarrow's high-output boilers and the triple expansion engine produced approximately 3,500 indicated horsepower in the Havoc, driving her single propeller shaft to the speed that the measured mile trial demonstrated. The margin between the contract requirement of 26 knots and the achieved speed of 26.5 knots was modest, but it was real, and it established that the ship was capable of catching every torpedo boat then in service. The armament was the other essential element of the design. The Havoc carried 3 12-pounder quick-firing guns, a weapon of 12-pound projectile weight that could be loaded and fired several times per minute by a trained crew, and that was capable of destroying a torpedo boat at ranges of several hundred meters. The quick-firing gun was itself a relatively recent development, made possible by the introduction of brass cartridge cases that combined the propellant charge and the projectile in a single unit that could be loaded rapidly as a complete round, rather than requiring the separate loading of powder and shot that made the older muzzle-loading and early breech-loading guns so slow. The 12-pounder in its naval form was a weapon that a well-drilled crew of 2 or 3 men could fire at rates of between 6 and 15 rounds per minute, depending on the specific loading arrangements and the physical demands of the sustained firing cycle. She also carried 3 torpedo tubes, 1 in the bow firing ahead and 2 on the beam amidships, fitting 18-inch Whitehead torpedoes. The inclusion of torpedo tubes in the destroyer design was a deliberate choice that reflected both the offensive opportunities that a fast, maneuverable vessel might encounter against enemy capital ships and the recognition that the torpedo boat destroyer's mission might eventually expand beyond the purely defensive role of protecting the battle fleet from torpedo boat attack. A vessel armed with torpedoes could also be used to attack the enemy fleet directly, as the torpedo boats it was designed to destroy were intended to do, and the torpedo armament gave the destroyer an offensive capability that would prove important in the fleet doctrine of the following decades. The Havoc was 92 feet long, or approximately 28 meters, with a beam of 18 feet, approximately 5.5 meters. Her draft was about 5 feet forward and 5.5 feet aft. The crew complement was approximately 45 to 50 officers and men who lived in conditions that were extremely cramped even by the ungenerous standards of small naval vessels. The forward mess deck where the sailors lived was a low, narrow space, perpetually soaked with water from the bow wave in any kind of sea, hot in the engine room area and cold forward, with hammocks slung in rows so close together that the men could feel their neighbors' movements. The officers' quarters aft were marginally better, but still far below the minimum standards that the officers of larger warships would have considered acceptable. The discomfort of living and working in a 27-knot torpedo boat destroyer was not a design failure in the sense that the designers had made poor choices. It was a necessary consequence of the design requirements. Every additional meter of hull length, every additional ton of displacement used to improve accommodation was a meter and a ton that could not be used to achieve the performance requirements. The contract specified 26 knots. 26 knots required a hull of approximately these dimensions and a machinery installation of approximately this weight. The accommodation was what remained after the performance requirements had consumed the design margins. The Havoc's commissioning into the Royal Navy in late 1893 was followed almost immediately by the commissioning of HMS Hornet, her sister from Thornycroft's design, which achieved 27.5 knots on trial and established that the Thornycroft approach was capable of meeting and exceeding the contract requirement as well. The two ships were not identical, as Yarrow and Thornycroft had made different specific choices within the performance specifications, but they were close enough in concept and execution that both could reasonably be called torpedo boat destroyers in the same sense, and the subsequent contracts placed by the Admiralty drew on the design approaches of both firms as well as others. The comparison between the Havoc and the Hornet, and between these and the subsequent ships of the first destroyer generation, the class that was informally known as the 27 knotters, revealed both the promise of the type and the specific limitations that operational experience would identify as needing correction. The speed was there. The armament was adequate for the intended purpose. The seakeeping was marginal in the conditions the North Sea routinely produced. The hulls that had been optimized for speed were long and narrow and shallow, characteristics that combined to produce a motion in heavy weather that tested the most experienced crews and that in severe conditions was genuinely dangerous. The first time a Royal Navy destroyer flotilla put to sea in a North Sea gale, the reports that came back from the commanding officers were alarming enough to initiate an immediate review of the seakeeping standards required for the type. Hatches that had been positioned where they were convenient for access were found to ship water in quantities that threatened the safety of the ship. Crew members working on the forecastle in heavy weather were at serious risk of being washed overboard. The structural stresses on the long, narrow hull in a heavy following sea were severe enough to cause concern about structural fatigue over the life of the ship. The motion, a rapid, violent combination of pitch and roll that the crew described in terms that varied between colorful and unprintable, made sustained operation at fleet speeds in bad weather a serious physical endurance test for every man aboard. These problems were addressed in successive classes, with modifications to the bow form that increased freeboard forward, improvements to the hatch and companionway arrangements that reduced water ingress, structural reinforcements to the most stressed portions of the hull, and gradual increases in displacement that reflected the designer's recognition that the absolute minimum hull required to achieve the speed contract was also the absolute minimum hull that could be made safe enough to operate. Each class of destroyers built through the 1890s and into the 1900s was slightly larger, slightly heavier, and slightly less extreme than its predecessors, as the accumulation of operational experience modified the initial design philosophy in the direction of practical usefulness. The speed contracts themselves escalated, as each successive class was required to beat the speeds achieved by the previous class, and as the torpedo boats against which the destroyers would be measured continued to improve. The 27 knotters gave way to the 30 knotters in the late 1890s, and the 30 knotters gave way to the turbine-powered destroyers of the early 1900s, in which the reciprocating triple expansion engine was replaced by the steam turbine that Charles Parsons had demonstrated in his experimental vessel, Turbinia, at the Spithead Naval Review of 1897, driving her through the fleet at 34 knots in what remains the most dramatic, unsolicited demonstration of a new propulsion technology in the history of naval engineering. The turbine's advantages, a higher power-to-weight ratio, smoother operation, and the ability to sustain high speeds for extended periods without the mechanical wear that rapid reciprocating motion imposed on the earlier engines, made it the natural propulsion system for the higher-speed destroyers of the early 20th century. HMS Havock served in the Royal Navy for approximately 11 years after her commissioning before being sold out of service, an unremarkable career that reflected both the limitations of the early destroyer design and the pace at which the type was being superseded by more capable successors. She was not lost in battle and was not the victim of any dramatic incident. She simply became obsolescent, which is the fate of most pioneering vessels. The qualities that made them significant are precisely the qualities that stimulate the development of their successors, who inherit and exceed those qualities and render the original redundant. The Havock's achievement was not the specific service record she accumulated, but the design template she established, and that template outlived the vessel by a margin that no naval constructor could have predicted in 1893. The name Havock has been given to subsequent Royal Navy warships as the type she created continued to develop. The destroyer has been the Admiralty's favored name for a vessel of aggression, speed, and disruption. The name has been assigned to destroyers of the H-class in the 1930s, vessels that bore a relationship to the original Havock, similar to the relationship between an airliner and the Wright brothers' flyer. The conceptual connection was real, and the historical lineage was traceable, but the specific capabilities were separated by 40 years of continuous development that had transformed every relevant characteristic. The original Havoc had no weapons system that a modern naval officer would recognize as useful. Her 12-pounder guns would be inadequate against the aircraft, missiles, and anti-ship weapons that define the modern threat environment. Her 18-inch torpedoes would be outranged by virtually every anti-ship weapon in service in any navy today. Her speed of 26.5 knots was, by the standards of the Second World War, let alone the present, unremarkable. Her detection systems consisted entirely of the eyesight and hearing of her crew. Her communication was by signal lamp and by the shouted commands of her officers. What she had, and what has been inherited by every destroyer in every navy since her commissioning, was the concept. A fast, maneuverable, small surface combatant, capable of operating in direct support of larger forces and independently as circumstances required, armed with weapons appropriate to the threats it was designed to address, and adaptable to threats that had not yet been defined when the design was first drawn. The specific weapons have changed beyond recognition. The concept has not. The Havoc was 92 feet long and displaced 240 tons. The Arleigh Burke-class destroyer of the modern United States Navy is 509 feet long and displaces 9,700 tons. One is 38 times the displacement of the other. They share a name for their type, a designer's intention that they should be faster than and capable of defeating any small surface threat in their operational environment, and the basic principle that a fast, versatile surface combatant capable of carrying multiple weapons systems is more useful to a fleet than any specialized vessel that can do only one thing. Everything else has changed. The history of the destroyer is the history of naval warfare over the 130 years since the Havoc's trials, because the destroyer has been present in every significant naval campaign and every significant fleet action in that period, adapting its capabilities to the evolving threat environment with a flexibility that no other warship type has matched. The destroyer has fought torpedo boats and battleships, submarines and aircraft, shore installations and other destroyers. It has served as a scout, an escort, a fleet screen, a convoy guard, a shore bombardment platform, and a strike vessel. It has been the most dangerous ship in any fleet to serve in, and the most essential ship in any fleet to have. It has never been glamorous in the way that the carrier or the battleship is glamorous, because its work is inherently supporting rather than central, protecting rather than attacking, filling in the tactical gaps that the larger vessels cannot address. The Havoc created all of this by making 26.5 knots over the measured mile on October 28, 1893, and demonstrating that the torpedo boat, the great unsolved tactical problem of the late 19th century fleet, had met an opponent that could catch it, engage it, and destroy it. The naval officers who studied the trial results and read the subsequent reports understood immediately what they meant. The problem had a solution. The solution had been built. Everything else was refinement. John Isaac Thornycroft and Alfred Yarrow, whose competing designs established the parameters of the first destroyer generation, went on to build ships for the Royal Navy and for foreign navies throughout the subsequent decades, their firms becoming the core of British destroyer construction expertise and their design philosophies shaping the type through its most formative period of development. Yarrow's firm in particular became so closely identified with destroyer construction that the Yarrow boiler, the marine version of the locomotive boiler that had powered the Havoc, became the standard boiler for British destroyers through the first 2 decades of the 20th century, and the name Yarrow became synonymous in naval circles with fast, well-built small warships. William Henry White, whose specifications had defined what the destroyer needed to be, remained Director of Naval Construction until 1902, overseeing the development of the type through its first decade and watching the 27-knotters give way to the 30-knotters and the turbine vessels with the satisfaction of a man who had identified the requirement correctly and seen it met. His insistence on performance requirements that pushed beyond what the existing technology could comfortably achieve was the single most important institutional factor in the creation of the destroyer, because it forced the commercial designers to push their technology to its limits rather than staying within the comfortable margins of established practice. HMS Havock herself was sold out of service in 1912, 19 years after her commissioning. The exact date of her breaking up is not recorded with the precision that the subsequent history of the type she founded might seem to demand. She went to the breakers without ceremony, a worn-out small vessel whose useful life had been consumed in the routine of fleet exercises and training operations, her specific contribution to naval history not yet fully recognized by the service she had transformed. The recognition came later, as historians of naval technology began to trace the genealogy of the destroyer backward through its successive generations to the first vessel that met the requirements and demonstrated the concept. She was 92 feet of steel and steam and quick-firing guns, built in 19 months at a yard on the Thames, making 26.5 knots on a cold day in October of 1893. She was the first of her kind. The kind she was the first of is still being built, in shipyards around the world, in forms she would not recognize, for missions she could not have performed, by navies that have never heard her name. The destroyer endures because the problem that created the Havoc has never been fully solved. There is always a torpedo boat. There is always a small, fast, cheap platform carrying a weapon disproportionate to the cost of the platform, threatening the expensive, powerful vessels that the fleet has invested in. The Havoc was built to catch and destroy one version of that threat. The Arleigh Burke is built to catch and destroy a much later version of the same threat, using technologies that the Havoc's designers could not have imagined to address weapons that could not have existed in 1893. The threat changes. The answer is always some version of the same ship, faster than the threat, better armed than the threat, capable of operating in support of the fleet while remaining able to act independently. The answer is always, in some fundamental sense, the Havoc.